Hey everybody, welcome back to Calculus. In this video, we are going to put together a lot of different things that we've been learning about for the past few days so that we could pretty accurately graph a function if we really wanted to. So we're going to put all of our tests and derivatives stuff together and learn all of the things about this function g of x. So we have the function g of x equals 1/3 x cubed minus 2x squared minus 12x plus 6. And we want to find the intervals of increasing, decreasing, concavity, local maxes and mins, and points of inflection. All of the things. So let's go through these one at a time. First, we want to find intervals of increasing and decreasing. Remember, increasing means that f prime is greater than 0, and decreasing means f prime is less than 0. And according also to our first derivative test, knowing where our function is increasing and decreasing can help us classify our local extrema. So in order to find our intervals of increasing and decreasing, I'm going to find my derivative and set it equal to 0. This will help us to find our critical points and will also help us to find this interval of increasing and decreasing. So g prime of x is equal to x squared minus 4x minus 12. And again, we want to set this equal to 0 to find our critical points. If I factor this, I get x minus 6 times x plus 2 equals 0, which gives us 2 critical points of x equals 6 and negative 2. So we know that these are critical points where we will possibly have local maxes or mins. So in order to see if they are maxes or mins and to see where our function is increasing and decreasing, let's plot these on a number line to see where our derivative is positive and where our derivative is negative. So I have 3 intervals here. I'm going to pick a number in each interval and plug it into my derivative and see what's going on. I can pick any 3 numbers in these intervals. I'm going to choose -3, 0, and 7. So f prime of -3, I'm going to plug it into this version of the derivative, is equal to -3 minus 6 is negative, -3 plus 2 is negative, which gives me something positive. This means that our function is increasing from -infinity to -2. Now if I plug in 0, f prime is 0, is equal to 0 minus 6 is negative, 0 plus 2 is positive. So this is negative. Our function is decreasing from -2 to +6. And finally, f prime of 7 is equal to 7 minus 6, which is 1, positive, and 7 plus 2, which is positive. So this is positive. Our function is increasing from 6 to infinity. This also helps us to find our points of local maxes and mins, right? Here on this positive interval, this means that our function is increasing, and then we're decreasing. And then here we go from decreasing to increasing. That means that at -2, this is a local max. And here at 6, this is a local min. Of course, we also could have found this information by using the second derivative test as well. But we just happen to be finding intervals of increasing and decreasing, so this way was easier. All right, so at -2 we have a local max, and at 6 we have a local min. Okay, so we have our increasing and decreasing taken care of, as well as our local maxes and mins. Now we need to focus on concavity and points of inflections. Remember, something is concave up if the second derivative is positive, and concave down if the second derivative is negative. So let's see what our second derivative looks like. So g double prime of x is equal to 2x minus 4. And to see where this is positive or negative, I'm going to set this equal to 0 to give me x equals 2. This x equals 2 is my possible point of inflection, where the second derivative is equal to 0. Possible point of inflection. And now, as we did above, I'm going to plot this 2 on a number line. I'm going to choose a point to the left and to the right of it. I'll choose 0 and 4. Doesn't have to be symmetrical, but we can choose it that way. And now I'm going to plug these 2 points into my second derivative to see if my second derivative is positive or negative there. So g double prime of 0 is equal to 2 times 0 minus 4, which is negative. So I am negative here. This means that I am concave down. Concave down. And g double prime of 4 is equal to 2 times 4 minus 4, which is positive. This means that we are concave up. And this also means that x equals 2 is a point of inflection. So we can just call it a regular old point of inflection. So now if we really wanted to, we could draw a pretty good graph of this function.